section 5.2, our objective today is I can prove a quadrilateral is a parallelogram. And so first I'm going to give you the theorems that allow us to prove it, and then we'll look at some actual examples. So our first theorem uses the converse of one of the theorems that we learned yesterday. Remember that if a quadrilateral is a parallelogram, then both pairs of opposite sides must be congruent. Okay, and actually, before we do that, remember that the definition of a parallelogram is both pairs of opposite sides are parallel. So one of the ways that we can show that a quadrilateral is a parallelogram is to use the definition. And if we can show that this side is parallel to this side and this side is parallel to this side, then we can say that it is a parallelogram. So the first way is actually by the definition. The second way, or another way, I should say, is if both pairs of opposite sides are congruent. Actually, let's put this in. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so again, if I have A, B, C, D. So if AB is congruent to DC and AD is congruent to BC, so what the theorem says, if AB is congruent to DC and segment AD is congruent to segment BC, then quadrilateral ABCD is a parallelogram. Okay, so that's what the theorem says. The second theorem, another way that we can show that a quadrilateral is a parallelogram is if one pair of opposite sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. Okay, so we have to know this side's parallel to this side and this side is congruent to this side, or it can be either pair. So if I can show this is parallel to this and congruent to this, then the quadrilateral has to be a parallelogram. Okay, the next theorem. Remember the theorem yesterday, if a quadrilateral is a parallelogram, then both pairs of opposite angles are congruent. So now to prove that a quadrilateral is a parallelogram, we can use the converse. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so in this one, if I can show this angle's congruent to this one and that one's congruent to that one, then it is a parallelogram. And then the final theorem, remember yesterday we had the theorem about the diagonals. The diagonals of a quadrilateral bisect each other. Okay, so we're going to use the converse of that one. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, so in this diagonal, if I know that this is congruent to this, then I know the other diagonal bisects it by definition of segment bisector. And if I have this diagonal and I know this is congruent to this, then I know that the yellow diagonal bisects the green diagonal by definition of segment bisector. And so therefore the quadrilateral must be a parallelogram. Okay, so basically there are 5 ways to show that a quadrilateral is a parallelogram. Number 1 is by the definition. So show, both pairs of opposite sides parallel. Number 2 is show both pairs of opposite sides congruent. Number 3, we can show one pair of opposite sides congruent and parallel. Number 4, show show both pairs of opposite angles congruent. And the final way is to show the diagonals bisect each other. All right, so let's look at some examples. Okay, so example 1. If I have this diagram with this diagonal, this is A, B, C, D. And if I know this angle is congruent to this one, and this one is congruent to this one, can I conclude that this quadrilateral is a parallelogram? Okay, well, I have this line, and this would be the transversal. So this angle and that angle are congruent to each other. So that means this has to be parallel to this. So AD must be parallel to BC. And if I know this line and this line, and this is my transversal, then these are alternate interior angles that are congruent, and so therefore this line must be parallel to this line. So therefore, quadrilateral ABCD must be a parallelogram by the definition, because both pairs of opposite sides are parallel. Okay. Example 2. If I have this quadrilateral, PQRS, and I know this segment's congruent to this segment, this one is congruent to this one. Okay? And can I say that this quadrilateral is a parallelogram? Well, I know that this segment is bisected by the other segment by PR, but I don't know anything about PR, so I can't say that the diagonals bisect each other. Okay, so I can't use that. And I know that this is congruent to this, but I don't know anything about side PS or QR, so I can't say that both pairs of opposite sides are congruent. And I also don't know if PQ is parallel to SR. There's no information in the picture that would let me get that. So with the given information, we would have to say no. We cannot prove that that is a parallelogram. Okay, let's look at example 3. If I have this picture where this is 6, this is 6, this is 75, this is 105. Okay, then what else do we know for sure? Let's see. We know that this is congruent to this. And notice that this angle and this angle are two angles formed by two lines and a transversal. And notice that those two angles are supplementary. So therefore, this has to be parallel to this, because we have two lines cut by transversal and same side interior angles are supplementary, then the lines are parallel. So then we have one pair of sides both congruent and parallel. So therefore, yes, it must be a parallelogram. Example 4. If I know this is 12, this is 12, this is 100, and this is 100. Okay, well, I don't know anything about this angle, and I don't know anything about that angle. I know this side is congruent to this side. I can't say opposite sides are parallel. I cannot say opposite sides, both pairs of opposite sides are congruent, because I know nothing about this side or this side. I can't say one pair of opposite sides are both congruent and parallel, because this is congruent, but I have no way of getting that side parallel. Can't use opposite angles, because even though this one is congruent to this one, I know nothing about this angle or that angle. So I can't conclude anything, so this one is a no. Okay, and number 5. If I have this, and I know this is congruent to this is congruent to this, can I say that that is definitely a parallelogram? Well, I know that this diagonal is bisected by the other one because I know those two segments are congruent, and I know this diagonal is bisected by the other one. So therefore, yes, this has to be a parallelogram. All right, and let's do one quick proof. Given parallelogram WXYZ and MZ is perpendicular to WN, and NY, segment NY is perpendicular to WN. Prove that MNYZ is a parallelogram. And we have this picture. Okay. And let's see. So number one, we know that WXYZ is a parallelogram because that is given. Okay, so WXYZ. So that means that WN is parallel to XY. So we know that this is parallel to this, and that's by definition of parallelogram. So we know that is parallel to that. Okay? Then we also know that MZ is perpendicular to WN, and NY is perpendicular to WN, because that was given. Okay, so MZ is perpendicular to WN. So we know this is a right angle, and NY is perpendicular to WN. So we know this is a right angle. Okay? And we knew that because it was given. And then we know that MZ must be parallel to NY. Okay? So we're saying that this must be parallel to that, okay? And because we have these right angles, we know that those are parallel because for in a plane, two lines perpendicular to the same line are parallel. So now we know this is parallel to this. And now we have both pairs of opposite sides parallel. So then number 5, now we can say that MNYZ is a parallelogram by definition of parallelogram.